Swayam Prabha. Digital India. Educated India.
Welcome back my dear friends and students. A very good morning, good afternoon, good evening to all of you. This is the TQM2 lecture series under NPTEL MOOC, and this is lecture number 19, and we are discussing the factor model, design of experiments, how the factors are dependent, how you can build the model, what is the total sum of squares, then what is the total sum of the errors, what is the total sum of the errors coming from the factors themselves individually, what is the total sum of squares of the errors coming from the combinations, and so on and so forth. We found out what was and discussed in details what was the degrees of freedom based on the total sum of squares, and degrees of freedom we found the mean square errors. Based on the means of square errors, we found out the ratios which would give us the f values. Then we perform the f test to either agree or disagree with the hypothesis whatever was being framed. So, let us consider an example. So, and if you remember that the main two examples which have been discussing time and again in the last 18, I would not say last 18, is basically starting from the 8th to the 18th lecture, because till the 7th one it was all discussing with the basic statistics, probability distribution, then cumulative distribution, then what are the concept of point estimation, hypothesis testing, alpha, beta error, type 1, type 2 error, and all these things. So, and later on we did discuss the problem of the etching, and depending on the wattages, powers, then we consider very briefly the aluminum smelting, then we consider the material versus the temperature for the battery life. So, these were the three main, the first and the third were the main focus. So, again we consider the battery life example as given example 5.1. Suppose that before running the experiment we decide that the null hypothesis should be rejected with a high probability if the difference in the mean battery life between the two temperatures. If you remember, the temperatures were 15, 70 and 125. Between any two temperatures is as great as mean life is as great as 40 hours. So, thus a difference of d which is 40 hours is significant, and if we assume will be significant, and if we assume that the standard deviation of battery life is approximately about 25. So, then equation which we had considered about the sample size and the concepts of the difference coming into the picture would be given as with the values are as this. So, capital phi square was, if you remember, when we are considering the concept of the errors between the fx, errors in between the errors coming out from factors b, fx means factors a, then factor b, or coming by the combinations. So, if it is coming out from factors a or b, so you will find out that in the formula which I will try highlighting, this one. So, the value was n a d square by divided by 2 b sigma square. In the case when you are trying to find out the capital phi square for the other factor, it will be n b d square divided by 2 a sigma square, where d was basically the differences as we just mentioned. So, if when we put into the values for this example, it comes out to be 1.28 n. So, as the minimum value of capital phi square, assuming alpha equal to 0.05, we can now use the values on the appendix table 5 to construct the following display. So, depending of as we change n, the capital phi square would be calculated. If the capital phi squares are calculated, it will give us the degrees of freedom m and n depending on where n, m, n are being counted for the F distribution, and we can find out the beta value also. So, in the first column we have n values, the second column phi square, third column phi, then the numerator which is the degrees of freedom, the errors of degrees of freedom, and the beta values are given in the subsequent second, third, fourth, fifth, and sixth column. So, if you find out the corresponding graphs, so the graphs would be given as this. So, if we have the values calculated, so we plot basically capital phi for values of alpha, and along the y axis you have the probability of accepting the hypothesis. So, it's not exactly an OC curve, but it resembles the OC curve in different aspect. So, we have different values of alpha. So, the first set, so these I will just highlight, these are the curves of probability of accepting the hypothesis with respect to the capital phi value for alpha is equal to 0.05, and then I will change the color. Anyway, the color did not change. So, this is with the values for alpha is equal to 0.01, and you can find out the values of probability of accepting with respect to capital phi. So, assumption of no interaction in a two factor model. So, we will consider this. So, now we have considered that if there are no interaction between the factors, it means tau into beta suffix ij would not be there. So, these single factors. So, the effect would be coming from tau, which is for factor A, I is equal to 1 to A, and if you are considering the beta value, which is beta j, it will be j is equal to 1 to B. So, occasionally an experimenter feels that the two factor model without interaction is appropriate. So, he will model it. So, I will just highlight it. Here what is important is tau beta ij is not there. I is equal to 1 to A, j is equal to 1 to B, k is equal to 1 to n. So, analysis of the variance of the battery life assumptions and assuming no interaction. So, there would be material types. So, this is A's, temperatures effects, which is B's. So, there is no combination of material and temperature. So, the third so called row is missing. There would be errors, there would be total. So, if you add these three values, they should add up to the total. Degrees of freedom we know. The mean square obviously we found out using the sum of the squares and the degrees of freedom, and the F values will be given, and you can either reject or accept the null hypothesis. So, in the following table we assume that no interactions is there. So, as soon as the residual analysis is performed from this data, it becomes clear that the no interaction model is inadequate, because it will not be able to explain all the variations to the utmost level of accuracy. For the two factor model without interaction, the fitted values of the curves are, so I want to find out the average of the average of the average, which is basically mu hat, which technically is given by the values of y bar dot dot dot. So, that is one. Now, I want to basically find out the differences. So, the differences would be technically the errors is what? Errors would be the value of the actual y, which is y without the hat suffix ijk, minus y hat, because the estimated value suffix ijk. So, that is the error. So, if I want to basically find out the estimated value, so this is the estimated value, that will be equal to, now we will take the sum. Now, the sum would be taken for what? We would take the values of the sum for fixed value of I and all values of j and n, then fixed values of j for all values of I and n, add them up and minus the value of the average of the average of the average, which is given by y bar, which I am just circling. I have y bar dot dot dot. So, basically I add up, keeping one row, add up for all the columns and all the n's, then keep the column fixed and find out the average, and sum it up and find the average for all the rows and all the n's. So, plot of y bar ij n, and n means I am taking for all the values of k, which is dot, minus y hat ijk is the cell average minus the fitted value of the cell versus the fitted value would be shown. Now, the quantities which we found out may be viewed as the difference between the observed cell and the estimated cell measuring means that assuming no interaction is there. So, if there is no interaction, technically we are assuming the effects of A and B combined together is 0. Any pattern in these quantities is suggestive of the presence of interaction. So, if there is no patterns, which means they are on a standalone effect affecting the overall reading. So, figure 5.15, which we will see, shows a distinct pattern as the quantities of y bar I j dot minus y hat I j k, which is the estimated value of I j k, move from positive to negative and from positive and negative to positive, depending on how the assumptions and how the variations are. This structure is the result of interaction between the material and the temperature, which or factor A and B, which even though are present, we may try to ignore that, but the results would not basically point to that fact, that ignoring would give you the best answer. So, if I plot these values of y bar I j dot minus y hat I j k, that means I am trying to basically take any cell value I j and trying to sum up for all the n values minus the hat this minus this estimated values. So, if there is a change, so if you see the positive negative, so this is positive, this is positive, this is positive, 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 this is the negative. So, you see the trend here and see the trend here, it will give you that they as they are moving from positive and negative, obviously there is some interrelationship happening. So, that means effect of A and B is there. One observation per cell. So, occasionally one encounters a two factor model with only a single replicate, that is only one observation per cell is available. If there are factors and only one observation per cell is available, then the effect model is done like this. So, I will give you the equation. So, here n would not come. So, this is to be noted. The equation remains the same, which is mu, which is average of the average of the average minus tau I. Obviously, that would be the effect happening for only the rows, which is factor A, beta j, which is the effect corresponding to the factor B, which is from along the columns, and tau beta suffix I j is basically the combinations of the combined factors A and B. And obviously, epsilon I j would be there, not epsilon I j k, because those factors are not being considered and k is basically not varying. Here there are no tests on main effects unless the interaction effect is 0. Then the above model, when it is put in the factor, considering that the interrelationship of the factors is missing, which means value of tau I j not there. So, it would not be there. So, obviously, if I look this into this equation, y I j remains, mu remains, tau I remains, beta j remains, error remains. What is missing is the interrelationship effect of factor A and B. So, if you can basically extend that for A, B, C accordingly. A, B, C means more than two factors. A test developed by Tuckey. So, we remember the Tuckey's capital T test is helpful in determining whether interaction is present. The procedure assumes that the interaction term is of a particular simple form given the factor that it will be equal to. So, what you have, interaction is given by tau beta suffix I j. So, basically I will consider them to be interdependent of each other. It means that I can multiply tau i's beta j's multiply by gamma, a very simple constant, where gamma would basically be a unknown constant. So, this value will depend on the positive and negative effects of A and B when they are considered. Effects are independent, in the sense you can just multiply them and try to find out the effect. We may use a regression approach to test the significance of the interaction terms and then do the calculations accordingly. Computationally when you find out, so the sum of the squares corresponding to n, n means capital N is basically you are trying to find out, if you remember it is basically equal to a into b into small n. So, that will basically be, so you will basically have in the denominator, if you consider, you have the sum of the squares of a on a standalone basis, sum of the squares of b on a standalone basis. So, combination is not there. So, obviously they would be multiplied by their corresponding degrees of freedom. So, SS suffix a would be multiplied by a, and this one SSB would be multiplied by its degrees of freedom b, small b, and in the numerator you will basically have the sum of the squares of a, sum of the squares of b, plus the y square. Y square is basically the values I am finding out for all the values of i's and all the values of j's, because here the n value factors or the cells, if you consider, they were independent, so called independent with respect to k, which is basically from 1 to n. So, that would be divided by the degrees of freedom a and b, and you will basically multiply it by the sum of the multiply by the average of the average, not average of the average of the average. It is 3 times average is not being mentioned, it is 2 averages, which is y bar bar, this dot dot. So, I am trying to find out the sum, because this is not the average. My apologies, I should not have used the word average. Is basically I am trying to find out the sum of the squares, multiplying them, and those would be summed up from j is equal to 1 to b. So, that is for factor b, capital B, and I is equal to 1 to a, which is for factor capital A. So, with 1 degree of freedom, we can find out the sum of the square of the errors, which is for the residuals minus the n, n means that what we find out. With the degrees of freedom for the errors would be a minus b into b minus 1, a minus 1 into b minus 1 minus 1, because we are considering only one cell concept. To test for the presence of interaction, we find out the f value under the null hypothesis, which is given by the ratio of SSN divided by, because SSN would have a degrees of freedom given by 1. So, technically this is SSN by 1, which is the degrees of freedom as mentioned, divided by SSE by its corresponding degrees of freedom, which is coming from here. So, you find out the f value and test whether right or wrong, or in the sense that whether you accept or reject. The impurity present in the chemical products is affected by two factors for the battery example, or when you are considering. So, this is pressure and temperature, and then the data from a single replicate of the factorial experiment is shown in figure 5.10. So, what you have the temperatures along the first column. So, these are 100, 120, 125, 150, and the pressure values are whatever the units are 25, 30, 35, 40, 45 values are given. The cell values inside the matrix. So, if you consider the second column is 531, which is basically the pressure corresponding to the pressures of 25, and the temperature values are 100, 125, 150. Similarly, if I consider the third column for pressure 30, the values are 411. Similarly, for 35 pressure, the values are 643. Pressure value of 40, the corresponding values are 321, and similarly for the last pressure 45, the impurity data correspondingly for temperatures 100, 125 and 150 are 532, and then you can find out the y I dot, which is keep I fixed, sum it up for all j's, and another one will be y dot j, which means keep j fixed, sum it up for all i's. The sum of the squares can be found out, they come out to be 23.33. So, this is the value. The sum of the b values comes out to be 11.60 from here, just the simple calculation which we have done. The sum of the total square basically comes out to be 36.93, and the residual values would be coming out. So, this is sum of the total square 36.93 minus 23.33 and 11.6. So, this is 2. So, here if you see the residuals, technically the total sum would be equal to SS suffix A, SS suffix B, SS errors or residuals, plus obviously a term would have been there if you have considered SSAB, but that is not there if you remember. So, this is not here. So, that is why the calculations are simple. The sum of the squares for the non-additivity is computed from the equation which you have already considered. So, that value comes out to be 0.0985, and the errors comes out to be, once we find out sum of the squares, errors comes out to be 1.9015. So, to complete the ANOVA, we perform the test. The F naught value comes out to be 0.36. So, we conclude there is no evidence of interaction in this data. The main effect, the temperature and pressure are significant. So, this is given summarized in table 5.11. Temperature is there, pressure is there, they are non-nativity concept, errors are there, total. So, I find out 23.33 as already noted, 11.06 and 36.93. Degrees of freedom we know. Mean squares can be found out by the sum of the squares divided by the degrees of freedom. So, we find out the F values, which is the ratios of the sum of the squares, and divide by their degrees of freedom. From there we can find out the p value. Now, we will consider the general factorial design. The results for the two factor factorial design may be extended to the general case when there are levels of factors, as I said, A, B, C, so on and so forth. So, A would be of values from I is equal to 1, I consider I suffix 1, because there would be many such nomenclatures. I suffix 1 are is the nomenclature corresponding to the values of factor capital A, which and I suffix 1 changes from 1 to small a. Similarly, you will have for factor B the suffix given by I suffix 2, the value changes from 1 to small b. Then you will have basically have the factor C, the nomenclature is I suffix 3 small 3, I suffix 3, and the values of I suffix 3 changes from 1 to small c. So, it can be done accordingly. In general, they would be corresponding to this A, then B, then C, then D, E, F, G, H, so on and so forth for the factors, and obviously there would be a total number of observation in each sample size in each factors would be small n. So, when if you want to find the total number of observation for all the factors and the samples would be A into B into C, so on and so forth till the last value into n, small n. So, so their small n's are the replicates. We must at least have 2 replicates to determine the sum of the squares due to error if all possible interactions are included in the model. If all factors in the experiments are fixed, we may easily formulate and test the hypothesis about the main effects and interaction using the ANOVA model. For a fixed effect model, test statistics for each main effect and interaction may be constructed by dividing the corresponding mean square for the effect or interaction by the mean square errors. So, all these F tests would be basically of the upper tail or one tail test, either greater or smaller depending on whatever, but not in between. So, it will depend on the problem formulation which you have done. The number of degrees of freedom for any main effect is the number of the levels of factor -1, because it will be A -1, B -1, C -1, D -1, so on and so forth, and you can find out the degrees of freedom for the errors, and for the sum it will be, for the total it will be the sum of them. And the number of degrees of freedom for an interaction is the product of the sum of the degrees of freedom associated with the individual component of the interaction, and we can do the calculations accordingly. Consider the 3-factor model, which I have already discussed. I have been mentioning that, but I will still explain it more in detail. Now, consider the average. So, what you have is basically y suffix I, j, k, l. So, I is basically from 1 to A, j is equal to 1 to B, k is equal to from 1 to C. So, A, B, C are all smalls, and L is equal to from 1 to small n. Now, on the right hand side it will be mu. Mu is basically, now listen to me carefully, average of the average of the average of the average. That means, I am taking technically average 4 times, because I am summing it up for i's, for j's, for k's, for l's. So, that would technically be y hat, which is the predicted value actually it should be, and you can find it the errors accordingly. The next terms are individual factors of A, which is tau I, individual factor for B, which is beta j, individual factor for C, which is basically gamma k, and obviously you would not have any L, because that is corresponding to the nomenclature for N. Now, when I go to the next stage of combinations, combinations will be tau beta I j, tau gamma I k, beta gamma j k. So, let me highlight tau beta I j, tau gamma j I k, beta gamma j k, and obviously if I go to the next level, which is 3, will be tau beta gamma suffix I j k. So, this is one, and obviously there would be an error epsilon I j k l. So, I values basically are changing from 1 to A, j values are changing from 1 to B, k values are changing from 1 to C, and L values are changing from 1 to N. So, assuming that A, B, C are fixed, we get the following tables in the ANOVA. Now, this looks complicated, but is very simple. In the first column, we have all the sources of variations A, B, C individual, AB, AC, BC combined 2 at a time, ABC for error term and the total. So, obviously, sum of all of them would be equal to the total. Now, how do I represent the sum of the squares? It is very simple. SS suffix, now note down the suffix, SS suffix A for A, SS suffix B for B, I am just highlighting the suffixes, SS suffix C for C, SS suffix AB, which is for the combination of AB, SS suffix AC, which is the combination of AC, SS suffix BC, which is the combination of BC, and SS suffix ABC, which is the combination of ABC. So, you have the errors, you have the total. So, degrees of freedom would be A minus A1, B minus 1, C minus 1, and the degrees of freedom, when I consider them as a combined state, would be for 2 would be A minus 1 into B minus 1 for the first one, B minus 1 into C minus 1 for the second one, B minus 1 into C minus 1 for the third one, and if I go to the 3 combinations, it will be A minus 1 into B minus 1 into C minus 1 as noted. If I want to go for the errors, errors would be basically A, B, C. We have already done in the initial case, it was A into B back and others was n minus 1, it is A, B, C into n minus 1, and the total sum of the degrees of freedom would be A, B, C, n minus 1. So, the mean squares again ms with the suffix would give you the mean square for those factors, and the mean squares, if I find out for all of them, it will be sigma square would be the common part, see where I am moving my highlighter, and the corresponding addition would basically correspond to the fact which is AB or A or B or C or BC or AC or ABC. So, you can find it out and you can find out the F values. So, with this I will end this 19th lecture and continue more discussion about this slide and later on. Thank you very much. Have a nice day.